So our first example, we're going to be evaluating functions and inverse functions by looking at a graph. So in part A, it asks us to find g of 6. Well, notice the graph that's being given there is the g function. So they are giving us the x value, which means they're wanting us to find the y value. Well, if x is 6, that would be right here. We can move up and we find that the y value is 4. So g of 6 equals 4. That tells us we have the point 6, 4 on g. Now, if we're looking at part B, B is asking about the inverse function. Well, the inverse function isn't graphed, but remember the inverse function goes backwards. So this is like saying g inverse of y equals x. Remember how I said if one has the point AB, the other one has the point BA? So we'll read it backwards. So this time they're giving us the y value of 1. So if y is 1, then that will give us an x value of 2. So the inverse function would have the point 1, 2. In example 2, we want to determine algebraically if two functions are inverses. Well, if you recall from above, that means we have to determine if the composite function f of g equals x, as well as the composite function g of f equals x. Okay, that is what we need to find out. So let's do f of g first. So remember, we want to keep writing f of g means f with g of x being input. We replace that with the function x plus 1 over 2. And now we're actually going to put that into the f of x equation. So 2 times x minus 1. So instead of x, we're putting in the entire g of x function. So here the 2's divide out. We will be left with x plus 1 minus 1, which does in fact equal x. So every operation in there undo each other, so to speak, and we're left with just the variable by itself. So the f of g checks. Now we have to try g of f. So when we plug in f of x into g of x, we don't need the parentheses anymore. The 1's reduce, the 2's divide out, and we are left with x. So f of x and g of x are in fact inverse functions.